Okay, hello everyone, and welcome to the BBSim and Scalability Brigade meeting for January 17, 2020. A quick reminder that the meeting is going to be recorded and published on YouTube, so be mindful of what you share during the meeting. Let me share my desktop. Okay. Hopefully everyone is able to see the agenda. We only have one topic on the agenda for today. Is there anything else that we need to discuss? Good morning, Saurav.
Morning. I'm still driving.
Yeah, no worries. So the only topic we have on the agenda is to discuss about the state transitions in BBSim. If there is nothing else that we need to discuss, I think we can get started with this, but I don't expect the discussion to be very long. So basically, I had a discussion earlier this week with Praja over Slack, and we felt that we need to formalize a little bit what happens and when in BBSim, because we are starting to add new features like that, add and remove one new, power them on and off, and manage their life cycle. So we need to be mindful on how to drive this operation to avoid having the same instruction repeated 25 times in different places in the code base. If I can get my thing out of the way. So if we look in the BBSim documentation, there is a table that describes all the states transition and how can you get to that state and where you can go from that state. And we also have a diagram that tries to visually summarize all this transition. This diagram is getting a little complicated, I believe, so maybe the time to change the format to actually understand what is he saying. But the most important thing, I believe, is to define what action in BBSim correspond to which state. For example, where do we start listening for OMCI messages? Where do we send the ONU discovery indication? Where do we send the ONU activation indication? Where and this kind of stuff, and what do we stop and what do we restart when transition happens? So basically expanding this table to add this kind of information. This is a work that still need to be done. Is not the topmost priority in the project right now, because the biggest priority here is to get to scale. So is there someone that wants to help driving this process?
Yeah, hi Matthew. So I started working on that interactive thing. So I think I can take this providing state transition means with discussion with other members also.
Okay, that would be great. So I think if this makes sense for everyone, we can maybe do an analysis over the next week and come up with a plan or our finding during the next week meeting.
Yeah, I can come up with my findings and I'll send. So, like, if other people have a comment on that, then we can modify it accordingly.
Okay, yeah, that would be great.
Yeah.
Well, back to the agenda, one thing that I think is worth mentioning is that BBSim now supports the UNI link state alarm, thanks to Matt. And this means that even though BBSim is reporting for Uniport up to honors, it will report only one as active, and we will thus reduce the amount of flows and meters and groups that are provisioned when we try to scale up Volta. I haven't tried yet to bring up Volta with a meaningful number of ONUs after this change, but I'll try to do this today, and I'll let you know which kind of improvement I see.
Yeah, I tried on my laptop. That being said, I haven't run it a whole lot before at scale, but I ran up 200, and I'd say about 175 were able to AAA, just on my laptop. So I don't know how that compares to a floor. There was a few that were in initial mid download retrying. I'm kind of curious about that. And then there was one or two. There was one that never got past activating. But yeah, it's certainly, when you looked at ONOS, the number of ports versus the number of enabled ports were a noticeable difference. So hopefully that does help.
Well, I think that this is helping greatly, because I was having trouble to get 50 to authenticate before this change. So
yeah. So compared to what you've done before, like I said, shame on me. I haven't run it at scale a whole lot, but this is the first time I did, and so I have no previous experience to kind of compare to. But again, just on the whole thing on my laptop, BBSim and Volta, it was able to. It seemed to me, at least.
yeah, that's great.
The other thing to bring up, I think, in order for the sanity test to be use the new BBSim, I think a Helm chart has to be released, right? The 0.0.10 BBSim would need a Helm chart bump so that kind Volta would use it.
I think kind Volta will use it because by default it pulls down master of every image, but I release a new Helm chart.
Okay, I did a recheck on my patch that actually changes the ONU adapter this morning, hoping that maybe it would pick up and use the new BBSim, and it did not. So,
okay.
But yeah, that's the only thing getting in the way of merging that change.
Yeah,
the other thing that's kind of
I'll make a patch right away.
Okay. Another nice thing that's kind of a nice side effect of this is basically now BBSim will honor the commands to the Uniport to lock and unlock them. So in the handler, what it does now is if there is a set from the adapter to lock the uni, it will send an alarm saying the uni is down. And if there's a set to unlock the uni, it'll send an alarm that the uni, at least 257, is up. What that means is in any testing of disable and enable of the ONU, especially after the ONU adapter change gets in, it should simulate the flipping off and on of the Uniport. So it should simulate ONO seeing the port go away and then come back, which is what a real ONU would do. I didn't actually try that, but the way it's set up to handle or at least respond to those sets, it should behave that way.
Okay, yeah, that's a great news, because also because yesterday I was in the testing brigade meeting, and they're actually planning to start running their entire test suite over BBSim, if I understood correctly, to validate the test suite. So the closer we behave to the real device, the better it is.
Yeah, cool, good deal. Yeah, one other thing, I guess as part of the change mine on the ONU adapter, and it's kind of subtle and it's probably worth bringing up, is not only is it reporting uni-link state and acting on it, basically what's really there. It also on ONU adapter disable and enable. Before, we were kind of heavy-handed about what disable meant. It would actually stop the OMCI state machine and do a lot of kind of harsh things to disable the adapter or the instance that it really didn't need to, especially now with indications from real hardware working the way they should. There was no reason to actually stop the OMCI state machine if the ONU is not down, mostly because if we call it disable, really we just want the ONTG and the uni themselves to be disabled, but we still have a perfectly valid OMCI communication channel. So there was really no reason to stop the OMCI state machine because we could still get updates, we could still provision it. Again, the nice side effect of this is we're not cutting our legs off completely when you call disable. It really says prevent the uni from being usable to anybody else, or the ONU from being usable from anybody physically there, but keep the communication channel open. This actually kind of simplifies a few things and reduces some of the churn in messaging on disable enable.
Nice.
So it may not be noticeable in the testing because the ports will still be pulled, from ONOS and still be re-added to ONOS. But in terms of the ONU, it won't have to go through a start of the state machine and have to check if everything is still the same, because we never stopped the state machine and we have no reason to think anything has changed.
Okay, so enable disable should be faster than it was.
I think so. It should be. Again, once this merges, it all kind of started to make sense with the uni-link state changes. That the only time we should ever really stop the OMCI state machines is if we get an indication from the OLT saying the ONU is now cut off. You've been removed from being able to talk to the ONU. So now that's the only times the OMCI state machines, alarm or MIB, will be stopped. Everything else, if the OMCI communication channel is still alive, then no reason to stop anything.
Okay, that's good news. One thing that I wanted to mention in regard of scale is that so far in my experiments, I've not seen a big difference depending on the environment, meaning that I ran the test on my laptop, I ran the test on a physical machine that has 32 gigabytes, and I ran the test with Volta running on a physical machine with 64 gigabytes of RAM and BBSim running on a physical machine with 32 gigabytes of RAM. And the results that I see are very, very similar.
I think that makes sense, mostly because watching it while it was under load, the Python process, the twisted thread is really CPU bound to a single CPU. So, again, getting things off of that thread is truly important for that. So yeah, if we have, 32 CPUs thrown at all of it, and I'd seen read-write core may spike up to 500% in the busiest of moments. So 5 of the CPUs, read-write core may be keeping occupied, but ONU itself was never more than 115. So 1 CPU and maybe a little bit of another. OLT adapter was never above, at least when I was looking at it, 50 to 60% of 1 CPU. So yeah, the big spend was, at least in time, Python, the ONU adapter sitting on 1 CPU, and then read-write core spikes pretty busy for a brief moment. But again, nothing that would burden a 32 CPU or even really an 8 CPU system.
Yeah, it really looks like that the device lock in the OpenONU adapter is what is really slowing everything down, and that makes so that it's not really meaningful to run Vault on a bigger system.
Yeah. So
It's a good news.
something I've, yeah, well, I mean, it just means that, it's all backed up behind the one, discovery thread, or the one Python adapter, rolling through all of the discoveries. So that I think would help that a bunch. So something else too, I kind of was thinking about, and I'm going to experiment with it a bit, is when the indications come in for all of these ONUs at once to start activating them, I'm going to try and see what it would be like to queue those up and kind of batch them in groups of like 5 or 10. It seems like when 5 or 10 are going all at once, they can move pretty quick, but as soon as you have like 100 or 200 running at the same time, they all slow each other down. Yeah. So I'm curious if I let 5 run and then, give it some amount of time, or maybe even better, figure out if it's really finished and then let 5 more run. I think getting those done in series a little bit might free up the whole thing a bit more.
Yeah, so if you want to do a quick and dirty test, BBSim will keep sending ONU discovery indication unless it receives an enable and activate ONU call to Volta.
Okay. Yeah. I was thinking is, can we just ignore? I mean, just have something that says handle, say, 5 or 10 discoveries, and only when they're complete, or at least as they complete one at a time, you start accepting new discoveries. Basically just ignore discoveries until you have resources available to handle them.
Yeah, well, so I guess it's that halfway state, right? So the discoveries themselves are handled pretty quick, and on the heels of that is then the ONU indication, which is really the message that says Plum has been set up, and both of those happen pretty quick. The discoveries come in, those are all set up, Plum is set up, those are good. It's at that point right there, once Plum is set up, that we now proceed to have all 200 of them or 500 of them try to message all at the same time. So what I was thinking is even letting them get past discovery and then just not starting the synchronization process until some number of them are done might help. Because I don't know if it'll
But the question is, when do you know they are done? In the sense that as soon as they are sort of done, ONOS will start sending flows for them, and then you still have to do those flows, right?
Yes.
So when is done, right?
So right now, the way done is determined is when the OMCI state machines are set to start, MIB-sync is starting, there's a callback in the ONU adapter that says, when MIB is in sync, fire me off. Right now, basically, they all fire more or less at the same time, but the callback is asynchronous. So if we stagger them, let's say we start 10, and then we wait maybe some amount of time and start 10 more, or we have something in the callback that says, this instance is done, and then the queue handler can add more to the queue. Once the MIB-sync is called for any one, that's when it moves on past and into actually starting to download the initial MIB. The initial MIB right now that it's downloading is actually only 3 MEs now. It's gotten pretty small since most of it's moved to Tech Profile and Flow Push. So again, I'm not going to try to let it distract from templating because I'm moving on to that. But it just looked like this kind of queuing of the starting of the state machines would offset the callback to in sync, which is what starts everything else. And ONOS can't push anything until initial MIB is pushed anyway.
True. But wouldn't templating just negate the need for this queuing or batching?
It could, yeah. So again, this is why I'm not going to sink a whole lot of time into it. It was just noticing it when running under load. Yeah, I'm curious to see some of the behavior characteristics.
Yeah, cool. I think it might be good to do the pacing model as well. But yeah, because there are certain situations where, like for instance, there's a regional power outage where all the ONUs go down and then they all come back up at the same time, and the OLT just gets bombarded with all new arrivals.
Yeah. So I mean, there may be situations, like even if we're not completely rediscovering the MIB, it might be good to kind of slow roll some of those activations anyway. So again, it's and part of the reason I kind of think about doing it in the ONU adapter is that's the one place that really needs the protecting, right? The adapter should protect itself, and because we can't guarantee, like you said, if a whole county loses power and then all comes back all at the same time, there's nothing externally you can do to prevent that thundering herd.
Yeah, it's just like maybe the kind of like the OLT adapter level where it knows kind of what's going on, right? Yeah, I mean.
And it could be done in the OLT adapter too. That's one thing where the OLT adapter could also queue up these indications, both discovery and Plum activated, and spoon feed it to the adapter once it's certain things have happened.
Yeah.
The only trick with the OLT adapter is it no longer really knows what's going on after the Plum is set up, right? It says, oh, ONU indication, you have your channel, and then it doesn't really know if you do anything more with it or not. It knows indirectly because it happens to see flows come along later, but there's no real distinctive, I'm finished with the bulk of my chatter, now do other things.
Yeah. And just as a side note, I don't want to distract, but there's also, when we're doing like 58 time of day, right, there's potentially some work that the OLT adapter needs to do on behalf of all ONUs, for instance, but on a given pond. But we'll talk about that later. But yeah, so there may be some need for some kind of awareness in the OLT adapter as well. But, okay.
Yeah, and that could be just taken care of through signaling between the adapters, right? The ONU could signal the OLT adapter if it's in a certain state or not, and then the OLT adapter can take further action. Right now, it's pretty much a one-way thing. The OLT adapter sends indication to the ONU adapter, but there really isn't a whole lot in the other direction, but there could be.
Yeah, okay.
Anyway.
So Matt, I'm curious to know what your investigation of adapter restart led you to believe.
So
templating was the first thing to do.
So the way the MIB storage used to be done, and kind of part of the reason why we ended up having to back away from using it, is the way it was stored in etcd was kind of, there's I guess duplication of storage. There was the hierarchy where there's a device level, and then at the device level there's classes, and at the class level there's instances. The way it was coded and the way the keys are written, you can store everything under the device, or you could store a very minimal amount of stuff under the device, and then there's a separate key for a class, and then the instances under that class. So it could be very spread out, where you have keys for the device and the classes and the instances, or you could have it all stuffed under the device.
So by device, you mean the ONU device, right?
Yeah, a single ONU. So a single ONU device with however many MEs and then however many instances under those. The tricky part was the only time you ever really needed to query at the device level in that setup is if you do a ONU restart. Every other time in the code, it was always querying based on class. So it was built so that, I need to look up class for EVTO, and it would return all the instances. And usually those queries are onesie twosie here and there. The only time it was a device level one, which is the big spend, was when you bounced the actual ONU itself, and that was then just the one time.
Okay, but
So,
when it was not under device and it was under, say, all the EVTOs for all the devices, you would go to EVTO find the appropriate device. How would you find?
No. So it was never stored at where class was at the top of the list. It was always service, Volta, device ID, and then ET, service, Volta, device ID, and then PPTP. But you, in certain cases, you could say, I want to go to get service, Volta, device, and I want everything underneath. Yeah. But etcd just natively has no way to just recursively return everything. So you had to do that yourself.
Okay.
So how does it relate to templating? Well, with templating, we are basically starting off with an entire device structure filled out. And the way we're using it in memory is more or less an entire structure filled out. And the only time we ever need to operate on the whole structure is when we do an ONU reboot. And it starts making more sense to just continue to operate the whole thing from memory and then write out the whole thing to disk in one key, in one value, and only read from that if you need to in terms of like an adapter restart. So it kind of started merging the two performance things together, where why are we bothering to always query for these individual classes if, one, I need to just fill out the whole device ID and work from it in memory anyway, and two, we could just as soon persist that to disk after either an ONU activation or a set of commits where it just updates the in memory and we lazy write out the whole thing to etcd in its own reactor process. So, I mean, long story short, it started turning into where one was going to affect the other in terms of how we load the template and then how we store it and then how we read from it. And it turns out that maybe with the templating, it might end up making sense to keep the storage more like it is now. And then after it's done, figure out how to do reconcile when we start moving into this template style setup.
Got it, thanks.
Okay, so we decided to work on the template before working on the reconcile, is that correct?
Yeah. So, yeah, sorry, that probably was glossed over, but yeah, basically, in doing one and then doing the other, it seems like it might make more sense to just do the templating, get that sorted out, and then once that's done, reconcile may present itself in a more performant way. It's probably the best way to put it.
Okay.
So when templating is in place, then BBSim's own state machine, OMCI, well, it's not quite a state machine, but BBSim will have to go through some changes as well, right?
It should not. So here's the trick. If the MIB templating works as it should, what will happen is initially the adapter, rather than asking for the command MIB upload, it'll start off with asking for 3 very specific entities. And those 3 entities will be used then to determine the template. Once that template has been determined and loaded in the adapter will not do the MIB upload sequence of commands and will just move straight into the initial gets and sets.
Right.
So,
I'm just making sure BBSim is that flexible. It's not that hard-coded that it expects something after something after something.
No. So BBSim basically has pre-canned response, but it looks at the OMCI message that it receives, it decomposes it, gets the entity ID and the class ID, and sends the appropriate response. So
That's great.
Be fine.
Okay, just making sure. Thank you.
Yeah. So, but like you said, it's worth testing because it's certainly a new behavior. But yeah, we just, from the point of view of BBSim and the ONU, it just won't be told the command MIB upload and then have to do the MIB upload next. It'll just move straight into gets and sets.
Cool.
Sounds good. I had another question that was bouncing in my mind in the last few days. That is like, once we'll have the adapter reconcile, do we still need to have a partition over Kafka to horizontally scale the ONU adapter? Because my understanding was that if we store the state in etcd, then the state is distributed and we don't need to associate one ONU with a particular instance of the adapter.
So the thing is that despite all of these, things like MIB templating, things like skewing the collection of, statistics from each ONU, you may, I'm just thinking, you may still, if you still find that the ONU adapter is too slow to deal with whatever 500 ONUs, at that point you will have to create other processes, right? So basically other instances of the ONU adapter, and that's at that point you'll have to divide up the ONUs to the different adapters by partitioning the topic. But that's like, we have to investigate to see, right? After all these changes go in, is it still too busy?
Yeah, it may not be needed to scale it, but if we do scale it, and considering that the OMCI state is now stored in etcd, at that point, any instance of the new adapter should be able to handle any instance of an ONU.
But then you'll have to change the partitions, and I think we decided that the partitions are going to be static.
But what I'm saying is that we may not need partitions, because if any adapter can manage.
So the other thing too is, just because all of the MIB state is in etcd doesn't mean the adapter is stateless. When it starts up, it will preload and walk through a reconcile process where it loads up all of the data it needs to work with a particular ONU. But what it'll also do is fill out all of its in-memory structures to handle, here are the 5 unis, and then here are the gems they have. There's these in-memory structures it uses to operate on the OMCI without having to hit storage for everything. So,
okay.
So it's not completely stateless. It's a little bit of both. It's a little bit of, query storage for when you need to figure something out new, but then in a sense of reconcile, there's this step of, is device loaded? When it's loaded, it doesn't actually try to go and re-download the MIB again or rewalk the MIB or push certain OMCI entities down to the ONU, because it's like, well, I have notion of it in my operating memory. The ONU has it, etcd has it. There's no reason to sit there and have to, check a bunch of things again.
Okay, so we'll still need to divide the news per adapter, though, because each adapter.
And I mean, it's not to say, and it's not to say that the ONU adapter couldn't be made to be more stateless, right? Some of this is just carryover from the way it was done in the past. But yeah, it's not in a place right now where it can just be wholesale, use any data anywhere and not now have some structure built in that has references.
Okay, thanks for the clarification.
Just one other clarification. So if the ONU goes down, isn't ONOS just going to withdraw all the service flows anyway, and then when it comes up, it's going to re-add them? So what does that happen? So to be clear, the device information that etcd has at that point.
So the one thing that the ONOS won't do is there's the setup of the initial bridge, and then there's the setup of adding the uni to that initial bridge. So initial MIB downloaded used to do a whole lot of stuff. It used to do way too much ahead of time. Now, like you said, it's more or less eventing off of ONOS. But there's like these 3 things left that are the sort of preliminary pieces. There's a chance that all of that could be moved to be more or less keyed off of the initial tech profile setup. Again,
but once the flow is withdrawn, the tech profile is not there, right? I guess you could assume it's going to be the same, but it might not be. Right.
So this is where when the ONU itself goes down and comes back up, there is a step where ONOS will overwrite what's there. If it happens to be the same, then in this case it could be coded to not actually change anything. But in this case, right now, it'll overwrite whatever's there either way. But there are some things, like I said, the initial download step that is done before ONOS or even before the core itself even knows that the ONU is ready.
Okay.
So, but again, that doesn't mean that we can't change some of that, right? Some of this is, we could move it slowly out so that now it's even less and less of an initial burden until ONOS pushes everything. So yeah, some of it is, you could argue, why store anything in the MIB if we're going to restart the ONU and it's all just going to get repushed anyway. Yeah, there's some scenarios there where that may, you know, why bother remembering so much in that case?
Yeah. Okay.
But you could also argue then at that point, do we need to be churning so much on provisioning in situations where we know nothing is going to change?
Well, I guess it becomes ambiguous, right? Because the ONU might go down, but it could be, you know, days, weeks, months before it comes back up again, and ONOS may have had a complete change in the provisioning for that subscriber, right?
Yeah. Oh, well, in the scenario I've seen, whereas if you restart 2 ONUs and one comes up sooner than the other, and they now swap to gem ports, you know, that can happen. Yeah, I mean, right now the way it's doing it is it's like, regardless of what you have before, you're going to remove the gem port or the TCON or the ALEC you have, and you're going to get this one now.
Yeah. Yeah. Right.
So, and again, so the scenario that I'm trying to think of now is, you know, in cases where, you know, maybe you know that something isn't changed, is it worth bothering replacing what's there if it's the same all the time, if it's still the same? Like, you could check in the MIB database and say, I'm about to tell you that your gem is 1025 and these are the various settings you're going to use. You check your own database and be like, well, what's on the ONU is still that, or should still be that, based on MDS or otherwise. There's no bother in trying to push this again.
Yeah, I guess. I mean, I guess you could ask new things are added back in again if it matches what's there, I guess. But is there any benefit to, you know, doing that as opposed to just doing it all over again?
Well, and yeah, so right now it does it all over again. It doesn't really check. But in cases where, like I said, if you can save yourself that bit of messaging, what does it gain you? And if you trust that the MDS is still meaningful and both sides still say they're 32, and I'm going to proceed to tell you to provision a gem, and I know everything that I'm about to tell you is the same, why bother?
Okay. Yeah.
But for now, it's
I'm just concerned with the ambiguity. Yeah, but okay. But obviously, one of my original questions was why store anything in XCD? But I guess because of the reconciliation that must happen, right? So but the data stored in XCD should be good, right? It's not like if the ONU's gone away, that data shouldn't really be there, except to get filled back in again with a template, and then
And well, the scenario there that it shows itself is if the ONU reboots, obviously there's going to be differences because the ONU forgot everything. But in the case of a fiber disconnect, reconnect, that's where it saves you, because now you're like, well, the ONU may actually still have good data and the OLT may still have good data, and we shouldn't have to, unplugging a splitter shouldn't force a whole lot of,
if the sequence number is still the same, that's fine. But in the case where it's not, then you really got to do it all over.
But I mean, a scenario now that comes up with unplugging the UniPort, since that is now reported all the way up into ONOS, unplugging a UniPort and replugging it back in will kick off some provisioning activity, right? We will, you could unplug a UniPort, you could plug a UniPort back in again, and those links.
Yeah, well, that's because you have to authenticate, right? But sure. Yeah, but I so once it goes down and comes back up again, you re-authenticate, but in theory nothing's changed on the ONU. But so those are the corner cases, I guess. But it's you cannot optimize, I guess, the behavior around that. But if the ONU itself goes away and is rediscovered, then all bets are off.
Well, the adapter. So this is where when all this pain is really realized is if the adapter restarts the way it's coded today, because we don't store the MIB and the adapter restarts and we have no idea what states the ONUs are in, we have to do a MIB reset on every ONU the adapter knows about, which is pretty bad.
Yeah. But that's a reconcile's job, right? I mean,
Yeah.
Okay. Okay.
Okay, guys, is there anything else we want / need to discuss?
Oh, is there a I don't want to put any pressure on anyone here, but is there an estimation of when like templates might be done and reconcile might be done? I think you had some kind of rough number of weeks.
A couple of 3. Let's go with a couple of 3 weeks. Yeah, there's a few things, at least in my personal environment, I need to sort out first, because the ONUs I have don't report back anything for equipment ID or the other one I need. So I'm have to either get a new firmware or just fudge my way through it. But again, there's some work there to kind of get that set up to make sure it doesn't break the whole state machine. But again, I think it's doable in 2 or 3 weeks.
Okay, that's great. This will be fantastic. I'm hoping.
Yeah, me too.
I'm praying.
Amen.
All right. Cool.
Okay.
Anything else? Yeah.
Matthew, so we had some comment on delete ONU, that pull request. So that process ONU message, that thread, as we decided, I moved it to initialize the state. But after that, those test cases were failing, because in those test cases, when we try to initialize ONU, now that process ONU message thread is also being started from there. But I tried fixing it, but in test cases, we are making mock OpenOLT stream. So if we move that process ONU message in initialize the state, so those test cases will not work actually.
Okay, I need to check. I haven't had the time to look at the changes you made yet.
Yeah.
I'll try to look at those today, and I'll drop you comments on the patch.
Okay, sure, thanks.
Okay, thank you everyone for your time, and have a good day or weekend, depending on your time zone.
Right, thanks a lot.
Thank you.
Bye.
Bye now.
Yeah.